an example here. Here's an example of a hydrogen. Remember, I told you hydrogen can change from one type of hydrogen to another if we change the number of neutrons. However, it doesn't cease being a hydrogen. Here we have H1, or 1H, which just means normal hydrogen. You notice that there are no neutrons in a hydrogen, so its atomic mass should be, on this first element, it should be 1. That's its atomic mass. We're not calculating for the electron, just the one proton, no neutrons. But you add a neutron to it. Suddenly, the atomic mass changes. It should become 2. And then you have that's known as deuterium, and tritium or tritium becomes also known as hydrogen isotope, where the atomic mass would be 3. Now, if you're looking on the periodic table, or if you were to look on your own periodic table, you'll notice that hydrogen is not listed as, its atomic mass is not listed as 1. It's usually listed as 1.3 or 1.8, I think is what's often listed as 1.8. Now the book shows all this as well, and it talks about it, and what's happening is that is the most common, is somewhere between H1 or 1H and 2H. Somewhere in between there is the most common way that we will find hydrogens. So therefore we get a number that falls right in between those two. It's not quite 1, it's not quite 2, but it's not actually, a full 0. So you actually have 1 point whatever that actually shows up, because it's showing the isotope that is most commonly seen, and that's how they put it on the periodic table. Now, let's talk about radioactivity. Page 31. Radioactivity. Radioactivity is simply this. It's still dealing with isotopes. Radioisotopes. These are heavy isotopes. Now, what's happening when you have radioisotopes is this. The heavier isotopes of certain atoms become unstable, or are unstable, and they tend to decompose because of their strong force is weaker than it should be to hold the atom together. And what is strong force? Well, it's kind of a complicated thing, but what's going on is positives and negatives attract to each other. Just in the chemical world, it's important to know that opposites attract. But the positive and positive should repel each other. Well, you got a little bit of an issue inside the nucleus of an atom, something that's going on there. And the question is, what is it? Well, you've got not, neutrons and electrons joined together in the center of the atom. You've got neutrons next to neutrons joined together in the center of the atom. They should be repelling each other and kicking each other out, but they're not. Something's holding them together. We call that strong force. That's the glue that holds these components together. Now, what's going on here is, in a radioactive isotope, is that the density of that atom has become such that it has enough neutrons that it becomes heavy enough that it's not holding together. The glue that's holding together is kind of weakening, and it starts to decompose. It starts to break apart. That means that it's said to be unstable. Okay? Unstable means that an atom is not going to hold its shape or its form on its own. So it's said to decompose until it becomes more stable, specifically a more stable isotope. So that means this atom is becoming weaker as it's and it's going to go through what we call radioactive decay. This radioactivity process of spontaneous atomic decay is known as radioactive decay, and it happens at a pretty steady rate dealing with some specific isotopes. One in particular that we use all the time is carbon-14. You've heard of carbon-14 dating. Well, that's based on radioactive decay. As soon as an animal dies and it drops this carbon-14 out of its body, that carbon-14 will begin to break down at a very constant rate, so that if you were to come across rock with carbon-14 in it, you might be able to date at least how old that particular rock is, based on its rock cycle. Yes, rocks have cycles.